All right, today we're going to talk about synthetic division. Now, I'm just going to show you the mechanics of synthetic division. If you want to know more about it or why it works, just Google why synthetic division works, and I'm sure there's lots of information out there. So first of all, synthetic division is kind of a shortcut for long division, but it doesn't work all the time. You can only use synthetic division when you have a simple binomial, and that would be when you're dividing by something that has two terms. The degree on the x is only 1, and the coefficient in front of the x is also 1. Now, there's a few tricks that we can do for other situations, but I'll show you those as we go along. So let's take this one for example. In synthetic division, you know that if I take something with a third degree and I'm going to divide it by something that's a first degree, you know that eventually your answer will be 1 degree less than what you started with, so your answer will be an x squared. So you really can ignore all of the variables and just use your coefficients. So you're going to put down 1, 5, negative 2, 4. And then you're going to divide it by negative 3. So think about as if you took this x plus 3 and set it equal to 0 and then solved for x. That's what you're going to divide by. So the first step is always to just simply bring down the first number. So there's a 1. I'm just going to carry it right down. Your next step will be to multiply the negative 3 and the 1. And you're going to put that underneath the next number, which would be 5. Then you're going to add 5 plus a negative 3 will give me a 2. And then you'll just repeat all over again. Negative 3 times 2 will be a negative 6. Negative 2 plus a negative 6 will give me a negative 8. I'm going to multiply negative 3 times negative 8 for a positive 24, and then I'm going to add. So the first three numbers here are the coefficients of your answer, and the last number will always be your remainder. So because I started with an x to the third, you know the first term will be 1x squared. Then the second one will be 2x minus 8, and then of course you're going to take your remainder and put it over your divisor. Let's try another one. So you're going to start with your coefficients, 4, 6, negative 2, 1. You always have to make sure that every variable here is accounted for. For instance, I have an x to the third, I have an x squared, I have an x, and then basically my last one is a constant term, or x to the 0, you can think of it. So this one here has everything accounted for. If I don't, if there was, for instance, no x squared here, I would have to put in a 0. But this is the case I do not have to. So 4, 6, negative 2, 1, I'm going to divide by negative 2. First step is to bring down the 4 and multiply and add and multiply and add and multiply and add. Again, the first three are going to be your coefficients, and the last one is your remainder. So it's going to be 4x squared minus 2x plus 2 plus a negative 3 over x plus 2. Why don't you pause the video and try this one on your own? Did you get 3x squared plus x minus 1? Right? Put your coefficients down. You don't have to put any zeros in. You're going to divide by positive 2. Bring down the 3. Multiply, add, multiply, add, multiply, add. This time you have a remainder of 0. Now this is the case where I have a 2x to the third, but I have no x squared. So in this case, you must put in a 0. If you do not put in a 0, you'll get an answer, but it will be incorrect. So now that you've put in your 0, everything else is the same. Bring down the 2, multiply, add, multiply, add, multiply, add. Your answer is 1x down from x to the third, so x squared. And then you have a remainder of negative 28 over x plus 3. Right, again, pause the video and see if you can do this one on your own. Did you get this as your answer? All right, so here now your last term will be a 0 because I have a x to the third, x squared, and x, but I have no constant term. I'm going to bring down the 1. The 4. I will multiply. I will add. I will multiply. I will add. I will multiply. I will add. I started with an x to the third, so my final answer starts with a 4x squared. Now this is one of those special cases that I had mentioned in the beginning where this is no longer divided by a simple binomial. It is 2 terms and the exponent is 1, but there's a leading coefficient of 2 here. So basically what I have to do is I have to factor out that 2. And if I do that, now x plus 1/2 is a simple binomial. But now I'm going to actually have to divide this in 2 parts. First I'm going to divide by the negative 1/2, and then I'll divide by 2. So let's first do the negative 1/2. Bring down the 2. Multiply, add. Multiply, add. Multiply, and add. But now I still have to multiply by 2. So I'm going to take just the coefficients, not the remainder, and divide those by 2. So my answer will be x squared minus 2x minus 3. And then I'm going to put the 7 over 2x plus 1. So in essence, I am dividing it by 2 because I'm putting it over the whole divisor. So don't forget, when there's a leading coefficient, you have to divide in your last step. Star that in your notes because that's often what kids forget. All right, put the video on pause and see if you can do this one. Did you get x squared plus 5x minus 2? All right, you're going to factor out the 3. You're going to divide by 1/3. I have x to the third, x squared, x in a constant term, so I don't need any zeros. I'm going to bring down the 3. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply, and I'm going to add. I'm going to now take my coefficients and divide them by the 3 that I factored out, and I'll get x squared plus 5x minus 2. Now this is an interesting example. Find k so that x minus 3 is a factor of 2x to the third plus 3x squared plus kx plus 15. So remember, if it's a factor, that's telling you that the remainder will be 0. So let's go ahead and do synthetic division and see where that leads us. So I have my coefficients 2, 3, k, and 15. Those are my coefficients. And because I'm going to divide by x minus 3, I'm going to put a positive 3 out here. I'm going to carry out my synthetic division like I always do. I'm going to bring down the 2. I'm going to multiply. I'm going to add. I'm going to multiply. But now when I add, I have unlike terms. So I just have to put k plus 27. Now when I multiply, I basically have to distribute that 3. I'll get 3k plus 81. And now when I add, I'm just going to combine my like terms. I'm going to add the 15 and the 81 to get 96. But now this is my remainder. 3k plus 96 is my remainder. But because it's a factor, I need that remainder to actually be 0. So I can say, well, I know that 3k plus 96 has to be 0 because you're asking me to find a factor. And now I can just solve this equation for k. So when k is negative 32, x minus 3 would be a factor. This one's very similar, but instead of having a remainder of 0, now I'm saying I'd like a remainder of 4. Why don't you put the video on pause and see if you can do this one. Did you get k equals negative 12? All right, put down your coefficients. I have x to the 4th, so I'm going to put a 1 there. I have x to the 3rd, so I'm going to put a negative 6. But I have no x squared term. Did you forget that one? You have to put a 0 in. And then I have minus 2k and k. I'm going to divide by negative 2. I'm going to bring down the 1. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply. But now I have unlike terms, so I'm going to add. I'm going to multiply, distributing the negative 2. I'm going to add. 5k plus 64 is my remainder, but I want my remainder to be 4, so I'm going to set it equal to 4 and solve for k. So once again, this is not a simple binomial, so I have to kind of think of a way to trick it so that I can actually divide by a simple binomial. Well, if you notice, this is really the difference of a perfect square. So I can say, well, this is x plus 2 and x minus 2. So I can actually just carry out my synthetic division twice. Put down all my coefficients. I'm going to start by dividing by negative 2, but you could have just as easily started by 2. It's not going to make any difference. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. When you're doing it twice, this first one should always come out with a remainder of 0. I'm going to just carry these same coefficients, and I'm going to do synthetic division all over again. Bring down the 1. I'm going to multiply, add, multiply, add, multiply, add. I started with an x to the 4th, but now I did synthetic division twice, so I divided out 2 x's. So I know my final answer is going to be an x squared. So x squared plus 6x minus 3.